So some more notes out of section 4.3. We're going to look at here evaluating trig functions. But we're not going to restrict ourselves to just using acute angles. We're going to use any angle that we want here, and not just between 0 and 360, any positive angle, negative angle. Talk about how we can evaluate these trig functions. And I'll list out kind of a series of steps that I find useful here. So I'm just going to dive right into an example. So let's say I wanted to evaluate the sine of pi over 3. I wanted to know what that equals. So I've got some steps. So here's my first step. You want to identify what theta is. So in my case, my theta, my angle, is pi over 3. And pi over 3, what is that? Well, pi radians is equivalent to 180 degrees. 180 degrees divided by 3, that would just be 60 degrees. So my theta here is pi over 3 radians, or if it's easier to think in degrees, then it's pi over 3 radians is equivalent to 60 degrees. Okay, so step 1, figuring out what your angle is. Step 2, draw theta in the plane. I'm going to draw it in standard position. So I'm going to draw my axes here. Here's my axes. And I'm going to make a 60-degree angle in standard position. So that means one of my sides is the x-axis. My terminal side is going to be in quadrant 1, making that 60 degrees. So I'm drawing theta in the plane. Step 3 is I'm going to make a right triangle that is perpendicular to the x-axis. I'm going to drop down my perpendicular here. It's got to be perpendicular to the x-axis. Okay, now step 4 is going to be to identify the reference angle. The reference angle is the central angle, the angle that's between the terminal side and the x-axis. So it's between the terminal side and the x-axis. So in this case, the reference angle is exactly what my original theta was, 60 degrees. That's what's between the terminal side and the x-axis. Okay, now I'm going to label my sides. And I'll throw in a note here. Watch out for negatives. Because I'm labeling this based on where I fall in the plane. So here in quadrant 1, all my sides are positive because the x values and the y values are positive in quadrant 1. So opposite 60, I'm going to have root 3. The 30 degrees is up top, so opposite that I get the 1, hypotenuse of the 2. And then my last step is to just evaluate. So I look at the reference angle, which is 60 degrees, and I figure out what is the sine of that angle. Well, opposite over hypotenuse, since I'm evaluating sine. So my answer is root 3 over 2. And that's my answer. Now, I made these steps in great detail so that you could reference them and get good at them, but pretty soon we'll be able to do most of those steps in our heads just by lots of practice with evaluating trig functions. So we're basically just going to get really awesome at these steps as the year goes on. So let's look at another example. Let's try to figure out the cosine of 7 pi over 6. So I'm going to do this, I'm going to kind of talk through the steps, but I'm not going to write out like 1 through 6 explicitly, but I'll kind of talk through them. So I'll figure out what my theta is. Well, it's 7 pi over 6 radians. Well, pi over 6 radians, that's 30 degrees. 7 times 30 degrees, that's 210 degrees. So my angle's 210. So I'm going to draw in an angle of 210 degrees and draw in a triangle. So 210, starting from that positive x-axis, 210 would put me in quadrant 3. So that right there would be 210 degrees. So now I make my triangle perpendicular to the x-axis. Now I have to identify the reference angle. So the reference angle is going to be in here. It's on the inside of the triangle always. Well, 210, that's 30 degrees more than 180, and I've gone past 180, so that means that my reference angle is going to be 30. Now I can fill in the sides of the triangle. It's going to be a 30, 60, 90 triangle. So opposite the 30 is a 1. Across from the 60, root 3. Hypotenuse is a 2. But I got to be careful here with my negatives. Both the 1 and the root 3 are negative because look at where I am in the coordinate plane. In quadrant 3, x values are negative and y values are negative because I've gone left and down to get to that vertex of the triangle right there. So the negative just indicates on the sides, the negative just indicates where I am in the plane. So my side lengths are still 1 and root 3. The negative 1 just indicates that the y value of this point right here is negative. And the negative root 3 just indicates that that x value is negative as well. The hypotenuse is always positive. So I'll throw that up on step 5. The hypotenuse is always positive, no matter where you are in the plane. It's always positive. Excellent. Now, looking at my picture here, I just have to evaluate what the cosine is, and I'm going to look at that reference angle of 30 degrees, looking right there, and evaluate the cosine, adjacent over hypotenuse. So it's going to be negative root 3 over 2. Excellent. So let's try one more. Let's try the secant of 7 pi over 4. Okay, so my theta is 7 pi over 4 radians. What is that in degrees? Pi over 4, that's 45 degrees. 45 times 7, that's 315. So I'm going to draw my picture. 315 degrees would put me in quadrant 4. All the way around there. 315, because that's more than 270, but less than 360, so I haven't gone all the way around. Make my triangle perpendicular to the x. Fill in this reference angle here. Well, I've gone around 315 degrees. I would have to go 45 more degrees to get all the way around, back to where I started. And 315 plus 45, yep, that gives me 360. So that inside reference angle must be 45 degrees. So it's a 45, 45, 90 triangle. Label the sides. They'll be 1, 1, root 2. Hypotenuse is always positive. So now it's positive root 2. This 1 in the x direction, that's positive, because look at where I am in the coordinate plane. Look at where this vertex is down here that I'm dotting. To get there, you have to go right and down. So the x value, positive 1. The y value, though, it went down. That's a negative 1. Now I need to figure out secant, looking at the reference angle of 45 degrees. Secant is hypotenuse over adjacent. The hypotenuse is root 2. And the adjacent is 1. That is just simply equal to root 2.